One of the advanced networking services that's been available to production workloads is a thing called a load balancer. Provides high availability and tolerance capabilities that you don't want to have just one service providing something, because if it goes down, you lose it. Or from a performance perspective, you might want to be able to scale that as demand increases. This is what load balancers are going to do. We've got a variety of them available, and in this lesson, we're going to take a look at what are the different kinds of load balancers, and we're going to focus on a traditional load balancer. My name is Bob Tickleman. I'm excited to be your guide for this load balancer networking module. Let's get into it. I mentioned that there's a wide variety of different load balancers, some that are unique within Azure. While they may be available from other cloud providers, we'll take a look at the Azure services, but we're going to focus in on traditional standard load balancers. So if you've been using these, we're going to move from a physical load balancer and we're going to move into the virtual world of Azure. We're going to take a look at the different types, as I said, the different SKUs that are available, and see what you can do, and I'll be then doing a demonstration of the load balancer. I mentioned that there's several options available for load balancing, and they break up into a couple of different categories. What we're going to be covering in this module is the traditional load balancer. It has a lot of the standard features you're working with, and you'll also see that we have the capability of not just using an Azure load balancer. There's a wide variety in the marketplace that I'll demonstrate to you in the demo from traditional providers. So if you have a existing load balancer infrastructure that you have a management plane for, you don't have to learn a new plane of management to manage this one in Azure. So if you're using some third-party product, you might want to try and deploy one of those services. Said I'll be doing that, but I'm going to focus on the Azure load balancer that provides that product for you. Now, when you take a look at a traditional environment, you're seeing that this is a regionally based resource. We've shown you in other recordings that a region is a space inside of Azure that is location based and based around a number of multiple data centers in a region that you're working with. Load balancers, the Azure one, is a regionally based resource. Now, an equivalent of this that will be covered in another recording is a thing called the application gateway. This is a software-defined or layer 7 load balancer where the traditional load balancers will be done at layer 4. The application gateway as a layer 7 in the OSI model provides this capability as well as some additional features that you wouldn't get from a traditional load balancer. And said we'll be doing that in another recording. Ones that are not going to be part of this series at all are a service called Front Door and Traffic Manager. These are both global-based routing systems, so that if you have traffic that maybe is a global service that you're offering it in Europe and several locations in North America, you're offering it in Asia, you're going to have a central entry point at a global level and then finding the resource at the one closest or most available to those users. So those are Traffic Manager and Front Door. Take a look at those two. That, as I said, they're separate from the recording that we're going to be doing for the load balancers we're covering. As I said earlier, a load balancer in Azure is basically a load balancer that you're used to if you've already been doing this in your on-premises or your existing networks. We're going to break it up into two major categories, what we call a public load balancer and an internal load balancer. And at the end of the day, they're exactly the same. The only difference is the ability to put an IP address, traditionally a public IP address, at the front end of the public-facing load balancer. So it can have a standard IP address that you're working with, whether it's a public or private one, but it has a standard IP address that it works with. Now, me personally, security is a big focus for me. I would typically not take that load balancer without putting something potentially in front of that. If this was a public IP address, it is going to then be potentially exposed to a whole bunch of nefarious traffic. So you might want to put something like a firewall in front of this to be the front end point that is going to filter that traffic. But basically the difference between a public load balancer, and we'll take a look at the next slide, this thing called an internal load balancer, is its ability to have a front end IP address. And then we're going to see that the load balancer itself across these two scenarios is 99.9% the same. The functions, the heartbeats, the configurations, the routing and shaping of the traffic across the load balancer is going to be the same for a public versus a internal load balancer. As I stated already, what you now have, and I'm going to say that this is a virtual machine scale set. This is covered in another recording when we take a look at our compute options. A virtual machine scale set is a dynamically expanding number of virtual machines that can have an entry point for the service itself. So something is going to be sent to the virtual machine scale set, and you can scale this out or scale it back in depending on volume and demand. And so I need my load balancer to potentially be able to scale to meet that demand. And now it's going to have a multiple entry point from the various number of machines that might be sending something to the load balancer. And what we take a look at is what its front end. In both of this is it's a front end and a back end. And on the previous slide, the same thing happens. Your front end, which is an IP address now, has a back end, and you'll often hear the term back end pool. So the load balancer at the end of the day, what it does is the same in both of these scenarios. Maybe how you get into it is going to be the only real difference as you go through this. When you take a look at determining which SKU you want to work with, and this has changed in the last little while and might change sometime in the future, knowing Azure, but we've gone from having very specific workloads on a specific load balancer, but we've now narrowed down the choices and put it into a single location. So as you go through and create the load balancer, you can see what kind of am I building. And we used to have a standard, a basic, and a public that you worked with. Those choices have gone away if you've done this before, and you're going to be presented at the time of this recording with, do I want just a standard, or do I want to have a gateway one, and is it a public versus internal? So they've made the choices. It's through a common graphical interface, and just depending on what you're trying to find from the configuration, is it needing an IP address, or is it going to be maybe some service like a VM scale set at the front end? And we'll be doing this in the demonstration. As I said, the absolute function of the load balancer is basically the same regardless of whether it's an internal or a public facing. What you have is that front end IP address or entry point into the load balancer, and then you're going to actually have a set of rules that will tell you how to process that flow to the back end. And so you can see that this is for public or private. The load balancer and the things that it does, virtually the same. So whether you build it as public or private, you're really just changing something at the front end. At the back end pool, you might have a dynamic scaling set of the VM scale set that you're working with. And there's a whole bunch of configurations that you can work with there's things like session-based. And so what we take a look at is the thing called a 5-tuple hash that talks about what is the pattern that I want to then send the values to the back end for load balancing. So I'm going to come back to that 5-tuple hash balancing and configuration in a couple of slides from now. But just know that whether it is a public or private load balancer, the creation of it is going to be basically the same. The rules that we're going to create we'll be showing you in a few minutes as we advance through the slides to show you how it's going to lock the traffic in. There's also things like heartbeat networks that you're going to have to configure to say, on a regular basis, how often will I be checking to see if that device is down? And what happens if it goes down, it's got workloads on it? How do I rebalance this? And that's really what it's going to do, is provide high availability as well as high performance capabilities by being able to potentially expand the back-end pool by adding nodes if needed to meet demand, and get rid of those if you're working with. And if one goes awry, how do I take the workload and then transfer it over to the other machines? And we'll take a look at this in other recordings, especially when we get into the compute node values, where we take a look at things called availability sets and scale sets. Now, before I go off and do the demonstration, this is that one that I was talking about the 5-tuple hash. The different ways in which we can route the traffic, and these become those rules that we're taking a look at. So you got a series of clients that are coming in, and so I can base it based on the source IP address. Where does it come? Where do I want to balance it off to? What is the source port? What is the destination port or IP address? And what protocols am I working with? And do I have that session persistence? So all of these different characteristics are ways for us to control traffic as we go through the load balancer on those rules that we created. Okay, with that in your belt, let's go take a look at the demonstration of this. Before I go into the specifics of an Azure Load Balancer, I wanted to show you that capability from the marketplace. I haven't done this in many of the other modules, but I wanted to show it here because it may be something that probably more pertains to some of you, especially if you've got a large investment in existing load balancers. I've come to the Azure Marketplace by coming in and create a resource, and I'm going to search the marketplace as opposed to what I've done in other modules where I've actually searched for the services that are an Azure service. I'm going to go in and take a look for load right here. And you can see that I'm getting asked about a wide variety of different type of load balancers that are out there. You can see that I think I've got a little over 43 pages of load balancers. They come from all the major providers. So if you have an existing load balancer, you'll see the same thing when we get to firewalls. If you've got existing products that you might have in your on-premises world and you have an entire bit of history and management plane to manage those devices, you might not want to add a different device to the mix. So if you wanted to take one of the major providers of it, don't want to just name any specific names, you could actually deploy one of their products inside of Azure and extend your licensing possibly to them, as well as then have your management plane and all the tools that you're using to be able to manage your on-premises and other locations, as well as Azure through that management plane. Now I'm going to focus specifically on the Azure Load Balancer. As we've done in other resources, I'm going to come in and pick a resource group. There's that choice that we were showing you in the slides. You can pick a standard or gateway. I'm going to pick standard, and do I want public or private? I'm just going to pick one. I'll come back to the internal and you'll see what some of the differences are. I have a front-end IP configuration, a back-end pool. If I go to public, what you would see is some differences on the back end. So what I'm going to do is jump back and forth, get into public. I have a front end IP address. What is the configuration I want to work with? I'm going to just cancel and switch back to an internal. Looks very much the same, but I've got some slightly different configurations for the drop-down shows the virtual networks that I'm going to be working with. So what is the name of it? RGBT demo. What virtual network do I want to attach this to? So I'm not going to have the chance to give it a public IP address. That was the difference I was trying to show between, but most of this stuff is going to be the same. So I'm going to come to my hub network. What subnet do I want to attach it to? And go to my web front end. Is the assignment going to be dynamic or static? And does it have an availability zone? These are all being talked about in the compute module when we get to it in another recording. We talked about your front end either being a service, maybe it might be an application, so a VNet that is running a VM scale set, and then what is the back-end pool that we're going to send this to. So I'm going to add my back-end pool. I'm going to give it a back-end name. I'm going to use it as a NIC that will then project it into this hub network. And once we deploy this, we'll go in and you'll see that network address, as I did in another recording where we were taking a look at the private endpoint where you had an IP address representing a private endpoint service. You'll see that now for the load balancer. Save that. You can define inbound and outbound rules. We talked about that. I'm not going to go into that right now. I'm just going to go through and review and create this. So that happens fairly quickly. So I'm going to go to the resource now. And it's in here that I could get into my front-end IP configuration. I can get in my load balancing rules that you want, the inbound NAT rules. So all the configuration can happen inside of here. But I'm going to go to that subnet and we'll see that its projection appears in there. So here I am in the hub network. Remember we had the 3 different subnets and I wanted this to go to my web front end subnet. If I take a look at my connected devices, there's my load balancer at that 10.1.1.4. So that was that front end. If you remember or seen any of the other recordings that I've done, I've been following very much a strict standard. And so that grabbed that first IP address, and there's my backend endpoint for a private link to the storage account. Let's go back to the presentation. So we saw the start of a load balancer conversation that is a regionally based resource. We've got them falling into the two major categories of regional resources and a traditional load balancer. Now, inside of that traditional load balancer as a term, Microsoft offers an Azure Load Balancer. Now, I would strongly recommend that you use the Azure Load Balancer because it is a true cloud native service. It dynamically expands and contracts based around the need and demand of the load balancer. So it's not something that has to be pre-configured and then potentially be over-provisioned, which you're paying too much for, or under-provisioned and not meeting your needs and meeting the requirements for the load that's being thrown at it. The Azure Load Balancer as an Azure scalable service will dynamically scale towards the needs that you have, and you only pay for what you use. We saw that you could pick potentially another party's load balancer to fit a specific model of deployments that you might already be using, but they will typically have constraints around the deployment of, much like you would in the physical world, I need X number of ports with this much memory, with this much throughput. You might have that same restriction if you go to those third-party load balancers. But we looked at the Azure Load Balancer. We saw that it came in two flavors, where you had a public or internal configuration. The load balancer does exactly the same thing, but the front-end pool was the difference between the two of them, and the back-end pools can be the same configurations you're dealing with. We then saw that the balancing is done through a set of rules based on that 5-tuple hash that is a standard for load balancer configuration. And know that in that 5-tuple hash, there's a configuration that you would get into to manage what is the heartbeat interval. So how often is it going to check to see that those devices are live and before they mark them as not usable for the load balancing and taking it out of the pool. Thanks for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.